Today we're going to look at graphing trig functions. We're going to look at the cosine and the sine. The first one is the sine, okay? Notice how the sine of x, the x-axis and the y-axis have changed. So your x-axis is now theta and your y-axis is sine of theta. We have a red dot on the circle, and this is going to go around the circle, and the blue dot is going to plot the lines as you go from 0 degrees to 360, or since we're looking at radians, from 0 to 2 pi. So let's see what happens. Notice upon looking at the curve that your maximum and your minimum is either 1 or -1. Remember that the radius of this circle is the unit circle, so the radius is 1. Okay, let's look at the cosine. So again, as you have plotted the points that the red circle goes through as it goes around the circle and it creates the purple line, notice how you start at 1 for a maximum, you go down to -1, and then back up to 1 at 2 pi. And if you think about the ordered pairs from the unit circle, that makes sense, right? All right, so let's see um, what other characteristics these waves have. The amplitude is the height of the graph measured from the middle of the wave. So remember, you have to be at the middle of the wave. Notice how it is in front of your amplitude is always the number that is in front of your sine or your cosine. To find your maximum or to find your amplitude, you need to take the maximum and subtract the minimum and divide by 2. So if you had from the last graph, you would have 1 minus a -1, which would give you 2 divided by 2, which is 1. So the maximum or the amplitude for those sine and cosine waves were both 1. So we're going to look here at a cosine wave, but now we're going to have an amplitude of 1/2. So that means that our cosine wave should be half as tall as the original one. Let's see. Notice how it started off at zero point 0.5. So notice how the only thing that has changed is the amplitude, how high or how low uh, the, the graph has gone. Okay, so it goes from 1/2 or zero point 0.5 as a maximum, -1/2 or -0.5 as your minimum. All right, let's look at the sine wave, okay? This time our amplitude is 2. So that means that this should be twice as tall. So let's take a look at that. Please notice that even though your amplitude is twice as tall, you're still going through the same point. You're still starting at the origin at 0 pi. You're still going through 0 pi the same, and you're still winding up at 2 pi, um, 0, 2 pi as well. It's just the amplitude has changed. All right, period of the graph is the distance along the horizontal axis of the graph to repeat. In other words, the length of one cycle. So far, that's all we've looked at is one cycle, and the lengths of our one cycle have all been 2 pi. Now, frequency is right in here, and it's multiplied by your x value. In order to find the frequency, okay, you have to take 2 pi and divide it by your period. Okay, so you'll have to take the 2 pi and divide it by your period, and that is going to give you the frequency B. Let's see what that looks like. Okay, so here's a sine wave, and now we're saying 1/2. Okay, so if I already know the frequency, then I can find my period. I can get an idea how long it's going to go along the x graph, okay? And notice how my period is going to change to 4 pi. So let's see what that's going to look like. Okay, notice how half of the graph, notice how this graph is extended. So when you hit 2 pi, you've only gone half the graph. Okay, so your b is 1/2, so the period is 4. All right, let's look at the cosine. This time our cosine is being multiplied by 2. Okay, so we're going to take a look at how that looks. So b is equal to 2 and the period is pi. So again, this would mean that your period would be equal to 2 pi divided by the frequency of 2, and that's where they get pi from. Let's see what this looks like. So notice for the cosine wave here that to do a full period, because we have doubled our frequency, that we only have to go to pi, and we've already gone all the way around the circle. Okay? If you're curious what tangent graphs look like, they look like this. And that's because the tangents have undefined areas. They have vertical asymptotes. Alrighty, and that is the end. Thank you so much.